Day 31, positive polyatomic ions. Today we're going to start out with +1 polyatomic ion, and it is ammonium. Ammonium is NH4, and this whole unit has a +1 charge. Then we're going to move on to +2 polyatomic ions, and we're going to look at mercury 1 and mercury 2. Now, mercury 2 is not a polyatomic ion. Remember, poly means more than one atom, and you can clearly see that mercury 2, there's only one atom here. The reason I included mercury 2 was to help aid in the distinction between mercury 1 and mercury 2 ions. Now, when we look at the mercury 1 ion, we'll notice that, hey, there's two of these atoms. There's two of these mercury atoms that are bonded together, and the whole thing has a +2 charge. Remember copper 1? When we said copper 1, we had copper with a +1. But now we're saying mercury 1, Hg. We're not writing it as mercury 1 like this. Mercury 1 has a +2 charge. And you think, well, what in the world is going on? Well, mercury 1 is one of those special polyatomic ions where there's not just one atom with a +1 charge, there are two mercury 1 atoms that are bonded together, and this whole unit has a +2 charge because there's one from this mercury and one from this mercury. So there's two mercury atoms, and the whole unit has a +2 charge. So that's how that works. And I think you can understand why I included the mercury 2 ion is to prevent any confusion from identifying whether the compound is mercury 1 or mercury 2. So let's look at some examples. Okay, we're going to start off with ammonium. The whole thing of +1 - 1 equals 0. Well, that's still valid. So what is ammonium? Ammonium is NH4. This whole unit has a +1 charge. And what's chloride? Chloride is Cl with a -1 charge. +1 - 1 equals 0, so my formula becomes NH4, and I have one of those units, Cl. And since I only have one of these units, we don't include the parentheses. What if I wanted to say ammonium sulfide? Sulfide has a -2 charge. Ammonium is NH4. It's a +1 charge. Sulfide, it's a -2 charge. We play the crisscross game, and we're going to get NH4 in parentheses, and that 2 is going to come down, and then the 1 is going to come down for the S. So NH4,2S, ammonium sulfide, just like what we have here. See, sulfide's got a -2 charge. I'm going to need two of these ammoniums. When we talk about nitride for ammonium nitride, nitride is a -3 charge. And since it's a -3 charge, I'm going to need three of these ammoniums. Ammonium nitride. Now we can take two polyatomic ions and put them together. Here's ammonium chlorate. Ammonium, this is NH4, this is a +1, and chlorate, ClO3, that's a -1 charge. I have two polyatomic ions here. So let's move on to polyatomic ions with other charges like carbonate. Carbonate is CO3, and the whole thing has a -2 charge. So ammonium, NH4, is a +1 charge. So ammonium carbonate, we still have to get to 0. So I'm going to need another one of those ammoniums, NH4 over here. I'm going to need two of those ammoniums and one of the carbonates. So we're going to get NH4, and then we're going to have subscript 2, CO3, ammonium carbonate, right here. Okay, good. Just like we got. So our math equations continue to work for us. We're building our vocabulary. We're just adding a polyatomic ion instead of a monatomic ion. We're just building our vocabulary, that's all. So ammonium phosphate. Ammonium is NH4, it's a +1. Phosphate, PO4, it's a -3. So I'm going to need three of the ammoniums and one of the phosphates in order to get to 0. Each ammonium is a +1, and one of the phosphates -3. NH4 3 PO4. So that NH4 has to be in parentheses. So mercury 1 chloride. Now mercury 1 is Hg2, and it is a +2 charge. Hg2, and it's a +2 charge. That is mercury 1. Now chloride is a -1 charge. I have to get to 0, so I'm going to need another one of those chlorides in order for me to get to 0. +2 -1 -1 equals 0. Now the next step is to write it, and we would get Hg2 in parentheses Cl2. Now, because there is only one of these units, there's only one of these in the parentheses, we ignore the parentheses and we get Hg2Cl2. Now the confusion may arise saying, oh, well, hey, there's a 2 here and a 2 here. Let's reduce. Oh, whoa, wait a minute. We don't want to do that because this Hg, the 2 of these mercuries for this mercury 1, this whole thing is a unit. You can't break that up. You cannot reduce here because this whole thing is considered a single unit, this Hg2. It's a whole unit bonded together. You cannot reduce. So the answer ends up being Hg2Cl2. Mercury 1 sulfide. Mercury 1's got a +2 charge. Sulfide's got a -2 charge. So Hg2S seems like a logical answer because +2 -2 equals 0. Now mercury 1 nitride. Mercury 1 Hg2. This is a +2 charge, and we want to mix this with nitride. Nitride's got a -3 charge. Play that crisscross game, and we're going to get Hg2, and then this is in parentheses. The 3 comes down, and then we have our nitride, and the 2 comes over. Hg2, all in parentheses, subscript 3, nitride, subscript 2. And then we get the formula for mercury 1 nitride. All right, so it's just like what we've learned before. The only difference is in certain circumstances it gets a little tricky because you may want to reduce, but you have to remember this whole thing acts as a unit, so you can't reduce. So it shouldn't be any surprise that mercury 1 chlorate, mercury 1's got a +2 charge, chlorate's got a -1 charge, so I'm going to need 2 of the chlorate ions and 1 of the mercury 2 ions. Mercury 1 carbonate. Mercury 1 has got a +2 charge, carbonate, -2 charge. Mercury 1 phosphate. Let's look at that one. Mercury 1, Hg2, +2 charge, phosphate, PO4. This whole thing has a -3 charge. So mercury 1 phosphate is going to be Hg2, bring down that 3, and then you're going to have PO4, and then bring down that 2. Mercury 1 phosphate. That's how it's written. So let's look at mercury 2. You see mercury 2 chloride, Hg is got a +2 charge. Chloride's got a -1 charge. So mercury 2 chloride, I need another one of those chlorides to get to 0, so that's going to be HgCl2, mercury 2 chloride. Mercury 2 sulfide, well, that's just Hg with a +2 charge because I only have one of those mercuries. And sulfide, that's got a -2 charge, +2 -2 equals 0, so therefore HgS. Mercury 2 nitride, Hg +2, nitride -3, bring them on over. So that's going to give us Hg3N2, mercury 2 nitride. Mercury 2 chlorate, Hg with a +2 charge. Chlorate is ClO3. It's got a whole unit here, a -1 charge. So I'm going to need 2 of these chlorates and 1 of these mercury 2s. So we'll get Hg parentheses ClO3, close those parentheses, subscript 2, mercury 2 chlorate. Let's write out mercury 2 carbonate. Mercury 2 is Hg with the plus 2. Carbonate, CO3, this whole thing has a negative 2 charge. Now when we play that crisscross game here, we're going to get Hg and we're going to bring that 2 down, and then we're going to write out carbonate, CO3, and then we're going to bring this 2 over. Now, notice in this case, these 2's will cancel, and they'll cancel because this mercury exists as a single atom, and there are 2 of those single atoms. This is not a polyatomic ion. Those 2's will cancel. And so our formula becomes HgCO3 for mercury 2 carbonate. Mercury 2 phosphate, hey, mercury 2 is a plus 2, phosphate PO4 is a minus 3. When you play that crisscross game, Hg3PO42 is your answer. Now what you could do is you could just go through and say, oh, mercury 2 plus 2, phosphate PO4 minus 3, I have to get to 0. I'm going to need 3 of these mercury 2's, and I'm going to need 2 of those phosphates, those PO4 minus 3's. So I'm going to write that out, and I'm going to get Hg3 parentheses PO4, and I need 2 of them. Mercury 2 phosphate. Now when you're wanting to name chemical compounds and you have something like this where you have Hg2CO3 and I ask you to name this compound, you have to know that, hey, this CO3, that's a polyatomic ion. You have to look out for those. This Hg may or may not be a polyatomic ion. Let's just wait and see. Here is this CO3, and I have 1 of those units, and carbonate has a negative 2 charge. Negative 2 times 1 is negative 2. I have to get to 0. Something minus 2 equals 0, and that something is a plus 2. And something times 2 gives us that plus 2 charge, and that something is a plus 1. This is mercury 1 carbonate. Then we can go to HgCO3 and we could say, well, hey, here's this Hg. Do I know if this is mercury 1 or mercury 2? Again, I look at the carbonate. Look at the polyatomic ion. Has a negative 2 charge. I have 1 of them. Negative 2 times 1 is negative 2. Set it equal to 0. 2 makes this statement true. I have only 1 of these mercuries, so this must be a plus 2 charge. Mercury 2 carbonate. So now it's time to practice on your own, so get after it. The best way to work these problems is to get out there and do it yourself. So get you a piece of paper and you practice. All right, have a great day.